Hello guys, we want to solve this question and they are exciting questions that I want us to look at. Now, let us solve, they are just 12 in number. Let us look at them and have fun with them. The first one says in the diagram below, that is the graph, then we have what? Sorry for that, this is V and this is T in degrees Celsius. They said if Charles' law is obeyed, point S is dash. Now, Charles' law states that the volume of a fixed mass of gas is directly proportional to the what? To the temperature, provided pressure is kept constant. Now that means that the relationship we are talking about is mainly on volume and temperature are directly proportional and pressure kept constant. So in that case now, when you plot the graph of this particular volume against temperature in degrees Celsius, it will cut the temperature axis at a point called absolute zero temperature. So the answer is B, absolute zero temperature. Now that value of that temperature is about 273.15 degrees Celsius minus or 0 Kelvin. Now the 0 Kelvin is different from 0 degrees Celsius. 0 degrees Celsius is what the lower fixed point of what of a thermometer. So why this one is what absolute zero what temperature. So the answer is B. Let's go to number 2. Number 2 say what amount of heat energy can raise up temperature of 500 grams of water contained in a 2 kilogram copper calorimeter from 5 degrees Celsius to 45 degrees Celsius. Now we are looking at this based on we assume that there is an heat that is supplied, and that heat is supplied to a container having a water of 500 grams. Now that container, that 500 water having a 500 grams has a copper calorimeter. That means the container is a copper calorimeter with 2 kg. Now that 2 kg now raise the temperature of the calorimeter from whatever 5 degrees Celsius to 45 degrees Celsius. So in other words, we can say whatever change in temperature that the water will experience will also be the change in temperature that the calorimeter itself will experience. That means the container. Now they must give us what? The specific heat capacity of copper. So copper, take the specific capacity of copper as 400 joules. Let's say specific capacity of copper it was as what 400 what joules per kilogram per Kelvin. Then let's take specific capacity of water as what 4200. It was given in the question. I failed to write it. Sorry for that. Now, having done that, now let's convert the mass of water. The mass of water is 500 grams. So we convert it to 0.5 kilogram by dividing by 1000. Don't forget to convert gram to kilogram divided by 1000. Therefore, we are given what change in temperature that will be experienced. Don't forget, since the water is inside the copper calorimeter, any change that the water experience will also be what the container will also experience. And that is what 45 minus 5, which is what 40 degrees Celsius. Now, what else do we need again? Okay, they give us mass of copper. The mass of copper is what? Is 2 kg. So what I'm going to do now is simply to eat what? Energy that will be that will raise the particular water inside that container is what? The mass of water and specific capacity of water and change the temperature plus mass of mass of water and specific capacity of water and change the temperature. The mass of what? Of copper and specific capacity of copper times change in temperature. So I'm going to have it as what? 0.5 times 4200 times 40 plus what? 2 times 400 times 40. We'll play with it. So this one will give us what? This times this will give us that is 20. 20 times 4200. 4200 times what? 20. That will give us 84000 plus what? This one will give us what? 8 8 plus we have 3200. So what do we have now? I'm going to have it as what? 8400 plus what? 32. I'm going to have what? 8400 plus 3200. So I'm going to have 002. This is 7, 8. So we are going to have it as what? Let's confirm this very well. This is 4 times 5, because this one will cancel this. That is 20. 0003 times this is 84. Okay, that one is clear. Then changing what temperature is for that. Okay. So this one now 00040 the 30 rather. Then 4 times 8 times 4 times 2 is 8 and 32. So that is 3200. Thank you very much for that. Okay. So this one is 000. I would have 6 and 11. So our answer is 116000 joules. So that's what I want to have. You must learn to play with numbers. You want to play with it. So that's why. Each what? So this one I give us what? 116 kilojoules. To remove the 30 and to replace with kilojoules is our answer. So the answer is D. Now they say two parallel conductors carrying current in the same direction will dash. Now, when you have according to Ampere's law, when you have two parallel currents carrying current in the same direction, what happens is that they will attract each other. But when they are moving, two parallel currents carrying current in opposite direction, they will repel. So like current attract, while unlike current repel. We know that F equals to what? 2 times 10 power what? Minus 7 what? I1, I2 over, well, let me put my L over what? Distance squared. That is the relationship between current that is flowing through the first wire, is let's say wire 1 and wire 2. Because wire 1 is what? I1, wire 2 is I2. So if you want to calculate the force, the distance between them is G. Maybe you have 2 wires now and they are giving you the current, they give you the current that's flowing through each of the wire, 2 parallel wire. According to Ampere's law, the product or the force is the product of what? The force per unit length of the wire is the product of the current what divided by the what? The distance. Is distance apart. So that is how it works. So this is. Now let's go. So the answer to that question is A. They will attract. If they are moving the same direction, please take on that. But if they are moving in the opposite direction, they will what? They will repel. Let's take on that. Now number 4 said the heat in joules produced in a heater is another calculation. That means this question has a lot of calculation. You have to be very fast. So I say what? The heat in joules produced by heater of resistance so R equals to 20 ohms. Then current is equal to what? 15 ampere. Then time is what? What is time? 4 minutes, 40 minutes. If you convert to seconds, you have 40 times 60. You have 2400 seconds. So they say we should calculate the heat. So heat is equal to what? I square RT or V square over RT or ITV. So which one will be better? So I believe that we can use V square R to I square RT. So if you use I square RT, we are going to have 15 square times 20 times 2400 time. So what we have now, this one is 225 times 20 times 2400. So what do we have? This one will give us 48. So 48 times what? Let me use my, I will not waste time. 225 times what? 48. 225 times. So our answer should be what? 1, 2, 3, 4, 5. That means what? Don't forget that this is what? 15 square. So what they give us here is 1.5. Sorry, it's 1.5 ampere. So it's 1.5. It's 1.5. Because if you use this, you might not get the answer. So you might not have the answer for that question. So that we can now have what? That means now be what? 2.25 is 1.08 times 10 to the power 5, which is joules. The same thing as 108,000 joules. Anyone that you see the option, you go for it. So this is our answer. So that current is 1.5, not 15. If not, you will not have the answer. So option D is our answer. They said a ray of light has a glancing angle of what? Of 60 degrees on a plane mirror. So this is a plane mirror. This is normal. So this is a ray, incident ray. This is angle to the angle of incident. And we produce what? Angle of incident, and this angle of what? Reflection. According to law of reflection, the angle of incident equal to angle of reflection. So they are equal. So I is equal to R. But the glancing angle is this angle here, which is what? 60. So angle of deviation is equal to what? 2 glancing angle. So what we have now is what? 2 times 60. We are going to have 120 degrees. So option B. Now they say, what is the mass of an object? This is another calculation. Okay. Very fast. They say, what is the mass of an object hanging from a spring balance with spring constant K equal to what? 450 what? Newton per meter. When extended by what? E equal to what? 20 centimeter. Okay? Was recorded when the extension of 20 centimeter was recorded. G, take G as what? 10 meter per second square. You see what? What mass? We are looking for mass. Now, according to Hooke's law, please don't do this one in your exam. I'm just only making it very simple and explanatory. So F equals to KE, because the force is proportional to E, provided the elastic limit is not what? Exceeded. And force equal to mg, which is used to measure. Mg, don't forget, is what? Is a weight, and we can use spring balance to measure it. Ke. So M is equal to Ke over G. What is your K? 450. Extension is what? 0.2. How do we get that? Divide by 100 to convert to standard unit, which is meter, the fundamental unit of length. Divide by what? 10. So this one will cancel this. So what do we have now? We're going to have what? 0.2 times 45, we have 9.0 kilogram. Now use your calculator to confirm it. So 9.0. Do you have there? Yes, B. 9.0. The next question say, how many what? 4 microfarad capacitor are needed to give an equivalent of 2 what? Microfarad, and total capacitance of 2 microfarad capacitor when connected in series. I want to answer this question. Answer it and send your answer to the comment section. But the answer is true, but answer it why, solve it and confirm it. Now, they say the transfer of disturbance from one wave from one point to another without the permanent displacement of the medium is what? Period is what? The time it takes to complete one, for a wave to complete one cycle or one oscillation. Then, wave is actually defining wave, the transfer of what? Disturbance from one point to another without what? The permanent displacement of the medium. That is wave for you. Then wavelength is what? Is the what distance covered what by wave for one circle, one complete what? Circuit. And wavelength can be what? The distance from crest to crest, or the distance from trough to trough, and all that. So let us just move ahead. So the answer is wave. Its wave is answer. Number 9 says very interesting. It says substance with permeability less than that of free space is called dash. Permeability less than that of free space is called dash. Now, less than that of free space. Now, what we have, what they call, there are 3 types of material. We have what the ferromagnetic material. These are what material that are strongly attracted to our what an external magnetic field. Even when the external magnetic field has been removed, they tend to retain their strength, their strong magnetic properties. And don't forget, the ferromagnetic materials are materials that the magnetic dipole moment tends to move in the same direction, tends to align in the same direction with the external magnetic field, and they align in the strength, the most strongest part of the field. Even when the external magnetic field is removed, they still retain this strength of that field. Now, don't forget of that material rather. Now, don't forget also the susceptibility of the ferromagnetic material is positive. It's very high. Then also, don't also forget that their relative permittivity is far greater than 1. It's far greater than 1. So, example of such is what we have: the cobalt, the nickel, the iron, the gadolinium, the permalloy, the nickel, and so forth and so on. So we have what they call the paramagnetism. Paramagnetism are those materials that are weakly attracted to an external magnetic field, and when the external magnetic field is removed, they tend to lose it. They tend to lose their they become weak, and they cannot retain their magnetism. Now, this is due to the unpaired electron that are found in these particular materials. And also, we notice that when you place them in a field, they tend to align themselves in line with the external magnetic field, then parallel to the external magnetic field. So, and don't forget also that their susceptibility, their magnetic dipole moment is in the same direction with the external magnetic field. That makes their susceptibility to be greater than 1. Now, don't forget when we say susceptibility is equal to what? Which is K equal to what? The I over H, which is intensity of magnetization divided by magnetization force. So that is what we call susceptibility. The ratio of intensity of magnetization to magnetization force. Now, don't forget magnetization is measured in ampere per meter, while that one is measured in normal Tesla. Now, don't also forget that in this case now, when you are talking about negative susceptibility, you are talking about diamagnetism. And before I forget, what are the examples of? You can use this shortcut. You can use you can use this formula. What does that mean? Aluminium, oxygen are paramagnetic. Magnesium, titanium, platinum, molybdenum also are examples of paramagnetic. So you can think of any other magnetism. Lithium, titanium, platinum, molybdenum, oxygen, aluminium. These are paramagnetic material, and they have unpaired electron. Now, another thing again you must know is that their relative permeability is greater than 1, not far greater than 1. I told you ferromagnetic is far greater than 1. How do we write that one? Write it like this. For ferro, this one is for para. Then for dia, their relative permeability is less than 1. So in the case where the permeability is greater or is less than that of free space, we are talking about a diamagnetism. When a permeability is greater than that of free space, we are talking about ferro. But when permeability is far greater than that of free space, far greater. Look at the word far greater, like maybe 1 million times greater than the free space within what? Ferromagnetism. Ferromagnetism. I believe you understand that now. So the answer to the question is C. I've explained a lot about it. Then number 10 say the average power distributed in an RLC circuit is what? This is. We can also write it as what? IRMS, VRMS times what? Cos phi. Where this one is power rate, the rating times what? Power factor. Or what we call the root mean square voltage and root mean square current, root mean current and root mean square voltage multiplied by power factor. We see give us this one I square. Don't forget what really causes power dissipation in an AC. You see the average power dissipated in an RLC series circuit again by is resistor, inductor, capacitor circuit, series circuit. Inductor and capacitor does not cause power loss, power dissipation in an AC. What causes power dissipation is resistor. Don't forget, one of the factors or function of resistor is that it helps to divide current, it helps to limit current, it resists flow of current, it dissipates heat or power in any circuit area. So that's what their function is. So this one, let's solve number 11. Number 11 now, quickly. Number 11 says the screw jack. What is the velocity ratio of a screw jack? 2 pi r over b. Here this p is pitch, r is the atomic bar length. They said what? The screw jack of pitch, p, 0.5 what? Centimeter. Okay, the screw jack of pitch, 0.5 centimeter, atomic bar, 10 centimeter long, has the atomic bar radius is what? 10 centimeter long. Has a what? A mechanical advantage. So let's calculate this velocity ratio first. VR will now be 2 pi times what? 10 centimeter divided by what? 0.5. So which will now give us what? 2 pi times 100 centimeter divided by what? 0.5 centimeter. We can write it like that by multiplying up and down by 10. So this one will cancel. 5 here, 20 times we have 40 pi. That is velocity ratio. What about mechanical advantage given to us? We are giving what? 10 pi. So what do you say we should find? You say the efficiency is dash. Yeah, we are looking for efficiency. A 40, B 25, C 30%, D 50%. So efficiency is equal to what? Mechanical advantage over velocity ratio times 100%. Or we can say power output over power input times 100%. You can also say work output over work input times 100%. You can even say power output or power input minus power due to friction, due to heat, over power input times 100%. Don't forget, power input removed from power due to friction will give us power output. So I say work input is equal to work output plus work due to friction. Don't forget, it's friction that really causes power loss in our power efficiency decrease. If the friction is negligible, it become an ideal machine, and in that case, it will be what? 100%. Then power output will now be equal to power input. So a mechanical advantage also will be equal to velocity ratio. Let's solve now. This one will be what? 10 pi over 40 pi times 100%. So this one cancel this one. This cancel. 4 here 1. 4 here 2 rather. Then 4 here. No, let me do it this way. This will cancel this one. Okay. Okay. So this one will cancel this one. Will give 4. So that is 25%. That would be better. So 25%. Now they say each set can easily work on pawn because of the action of dash. The answer to that question is what? Type it on the comment section. We shall see again. Thank you very much. God bless you. Have a wonderful day and remain blessed. Thank you for watching my video. Please like and comment. If you have not subscribed, do that quickly. Thank you.